Hello, everybody. Welcome to lesson 3 of the Romi Lessons. This is going to be introducing you to autonomous programs. And what that basically means is you're going to be giving the robot instructions, step-by-step instructions on how and where to go. So you're going to have them go like drive forward, turn around, come back. That's the one that's in there right now. And there's two different ways you could do this, two different methods for doing autonomous. So let's start with the lessons. So what is autonomous? Autonomous is, well, in the games, it's the first 15 seconds of the round. So we'll have 15 seconds to do whatever we need to do. So maybe we need to shoot a ball into a thing, and usually it's like double the points if the robot does it without human control, which is huge because the good bots, they usually can get the team maybe 50, 60 points right in the first 15 seconds because the autonomous is so it's so multiplied in the beginning. So if we can get a good autonomous on the main bot, we have a pretty good chance of getting picked in the qualifier, and then even moving on to regionals or worlds or whatever. But for the Ramis, they're pretty simple programs. We're just driving it with the motors. We're not shooting any balls. We're not really moving any servos, unless you guys want to do that as one of your final little things. But that's basically what autonomous is. So autonomous is basically taking some commands that you wrote. So maybe it's drive distance and turn degrees, right? And those are commands. So it's going to say your autonomous is going to call them. Actually, it's going to call your command group, and then it's going to say it's going to call drive distance here, and then next it's going to call turn degrees here, and then drive time, and then turn time, but only after each one of these is finished. So after it drives the distance, then it calls turn degrees. After it finishes getting to angle 180, it calls drive time. And there's two different ways of doing it. So you got the distance, which is using your encoders on the wheels here. So it'll actually measure how many inches it's driving forward using a little bit of math. And then the turn degrees, it's going to be using it's either the encoders again or the gyro to measure that. I'm not sure which one. Doesn't really matter for right now. But then the time thing is just going to be counting in seconds. So it's going to drive forward for 3 seconds, and then turn for 2 seconds. And usually, one's not better than the other, but usually you want to use the distance or the degrees because they're more accurate to what you want to do. Sometimes you don't have that option. Like maybe you can't get your encoders to work and you need to use the time instead, which does work. It's just a little less accurate. But yeah, those are two different methods. And usually on the big bot, we only use encoders or gyros for doing that. Okay, so this is the syntax for that. What's next? Okay, so let's go into the code. Okay, LED test. So we'll go into the code, and I put your auto commands all in this little group here. They're pretty much the same as your tele commands, which we now have LED test in there if you did the first one. But another really interesting part about this, and this is something that I haven't taught you yet, is command groups, which is a different way of calling commands, and it's usually only used for autonomous stuff because it's kind of tedious to set up otherwise. But the way this works is you have an autonomous command here, and when it's in autonomous mode, it's going to call autonomous, which is our command group, and it's going to give it drivetrain because we're moving the wheels. So it's going to call this, and then this is kind of the simple part is we're creating new instances of these commands. So it's going to call this one, and then this one, and then this one, and then this one, all the way down. And it's going to be calling these. So what I want you to do first off is just I want you to comment out what I put in here for you. And you can just copy and paste this syntax around. So you got 4 options here. Maybe a little bit later for your final thing, we'll add some more commands to it. But right now, we're just going to do this. And what this is doing, so drive distance, if we look in drive distance, okay, it takes in, so we have to give it speed, so the speed that it drives at, inches, so the distance that it's going to, and the drivetrain, which is your subsystem. So we give it inches, speed, drive, and then we call as requirements drive. It's going to set your drive speed to 0, so your motor's speeds are going to go to 0 for both. It's going to reset your encoders, so it's now at angle 0. And then it's going to be calling arcade drive, which actually moves it at this certain speed, no rotation, and then it's going to shut off your motors again at the end. And it actually ends from getting average distance, which is in M drive. So this is pretty simple. So all you got to do, take one of these. If you only have one in there, you're just going to do this. I actually don't like the way that they set this up, because it would actually look like this, and then you would have like a ton of these things in here, and it just gets too long to fit into the window. So we separate it out. But that's why you have commas instead of semicolons, because it's not actually finishing a line. It's just in this little parameter thing. So we're going to get rid of all that. And we're just going to do it like this because it's easier to read. So we've got drive distance in here. So I want it to drive forward at, let's say, forward speed 10 inches. That sounds good. And then I want it to turn around. We can do 0.5 speed. I think that's good. You don't want to go too fast. And 180 degrees. I feel like the degree thing was a little bit off last time, so we might have to correct for that just by adjusting this number here. But I'm going to have it come forward, turn around, come back, turn again, and then go to the side. So how do we do that? So we're going forward 10 inches, turning 180 degrees, and now we're going to go forward 10 inches again, because now we've turned around. Okay. Now I want it to turn 90 degrees, and I don't know which direction it is. It might be the negative direction, it might be the positive direction. I don't really care right now. This is just an example, and then we'll drive forward again 10 inches probably. Let's just do 5 inches to show that there's a difference. And then the last one doesn't need a comma because it's the end. So I think I deleted my parentheses. So there we go. What's the problem here? Why would you want that? You want it there. Okay. Alright. That should be good. Now we're going to connect to the Romi, and we're going to test out our little autonomous program. And it'd be kind of cool. I haven't seen anyone do this yet, but if you made a new auto command that like turned on an LED, or you could even call your LED test in here, because it doesn't really matter where it is. You just got to put in new and the command name. You'll have to import it, but we'll just do that, and then we'll give it. We don't have to give it anything. This. What does it need? Yeah, it needs the onboard I/O. So you'd have to import a new thing here, but that's just an example. This wouldn't actually work because you got to put onboard I/O in here and then give it onboard I/O, because this takes drivetrain and not onboard I/O. But that's okay. But you could make a new LED test and do that if you wanted to do that. We're connected to the Romi. Yes, we are. Let's make the robot code. So remember what we tried to tell it to do. I'm just going to hold it up here. Actually, I'll put it on the ground. See if you can see this stuff. Alright. There. Okay. So let's go down to the simulator. Let's just try driving it normally. Okay, it does drive normally. Alright, so we're going to try out our autonomous code. It's supposed to go forward, turn around, come back, turn, and then drive forward again. Make it like a little L shape. Let's see what happens. There we go. There's our L shape. And that, I don't know if that was quite 5 inches. It's more accurate when you slow it down. But yeah, that's the autonomous code. Pretty easy. You're just copy and pasting code I already have in there for you. So it shouldn't be too difficult. This is kind of the one that I got first. It's a little bit easier than the LED because you're not actually creating a bunch of stuff. But good luck. Ask me, ask me if you have any questions, and have fun.